Okay, so now my other example is the height of a ball thrown by a child is modeled by the equation y equals negative 2x squared plus 8. Looking at the equation, what can you tell me? It's quadratic, right? And why is it quadratic? How do you know?
An exponent.
Exponent what? 2. Degree 2, yeah? Okay, so I know it's quadratic. And I know that because it's a degree or exponent 2. All right. Now, I have to do the same thing with the table of values. In this case, they gave me the x values, and then I have also to find the y values. So I plug in the x values in for x. First example is negative 2 times 0 squared plus 8. BEDMAS says I have to do what first? The brackets, but there's nothing inside the brackets. It's already simplified. So I have to do my exponent. Yes? So I have to do 0 squared, which is 0, times negative 2, that's still 0, add 8, that's 8. Okay? So following the BEDMAS is very important. Let's do the next one. Negative 2 times 1 squared plus 8. What do I do first? 1 squared is 1. Okay? 1 times negative 2. Add 8 is 6. Negative 2 times 2 squared plus 8. 2 squared first. Okay? 2 squared is 4. 4 times negative 2 is negative 8. Add 8 is 0. Then I have negative 2 times 3 squared plus 8. Tell me, what do I need to do? Three squared is 9 times negative 2, that's negative 18. That's right. So negative 18 plus 8 is negative 10. Then it's negative 2 times 4 squared plus 8. 4 squared, 16. Times negative 2, negative 32. Plus 8 is negative 24. Okay. So we found our y values. Now, because it's a table of value, I'm going to have to do the first difference to see if it's linear or not. So first difference says I have to do the bottom minus the top, yes? So what's 6 take away 8?
Minus 2.
Negative 2. Then 0 take away 6. Then negative 10 take away 0. And then I have negative 24 take away negative 10. Negative 14, yeah? Because I have negative 24 plus 10. So that's negative 14. Is your first difference constant? No. Did you expect it to be constant? No, because it's not linear. The only time it's going to be constant, the first difference is going to be constant, if it's a linear equation. Okay? So, now since the first difference is not constant, that's going to force me to go to the second difference. Okay? So, the second difference is now doing the same thing, but for the first difference. Okay? So, I will have to subtract again, the first difference. So I'll do negative 6, take away negative 2. Negative 4. Negative 6, take away negative 2. Okay? So, for the second difference, I'm taking the first difference and I'm subtracting the second, the bottom minus the top. Then I have negative 10, take away negative 6. What do you get? Negative 4. Then negative 14, take away negative 10. Negative 4. Now, what did you notice? The second difference is constant. And that's going to be true for all quadratic functions. Okay? So, linear function, first difference is constant. Quadratic, second difference is constant. Are we good with that? Now I'm going to graph this. Looks like I need a lot of different points above and below. You're good? Do you have a question? So if I'm going to graph this, let's say I'll put it almost like here. I might not be able to fit all points, or I might have to go by 2. If you're going down by 2 or up by 2, make sure that all your y values are by 2s above and below the x-axis. Okay, so I'm going on the y value up by 2. Okay, make sure you do that for the whole y values. For the x values, I'm just going to go up by 1. So my first point is going to be 0, 8. That's going to be 1, 6, 2, 0, 3, negative 10, and then 4, negative 24. So if I'm going to draw this, as a linear function, it's not going to fit the other 2 points. So this is going to force me to go into a curvy function. Okay? Now, as you can see, this doesn't look like a U because it's missing the other part. Okay? Because I only took the positive values on the x. So basically, there is something that looks like this on the other side, but we're not going to draw it because we only have the positive value of the x. Okay? So it is going to be a parabola, but it's missing half of the parabola. Okay? Are we okay with this? I'll come back to this page. I just want you guys to go to, once you're finished copying this, what I want you to do is I want you to go to the next page and I want you to do this. All right? Be careful, follow bad math. Okay? When you're finding, either enter it all in the calculator as you see it. Make sure you follow BEDMAS if you're not going to use a calculator. Okay? All right.